Well, thank you. I sure appreciate this. Being first right after lunch, it has its advantages, I think. When we look at flooding, you can look in the developed areas of the world as well as the undeveloped. And so what we're doing is some work in Afghanistan. The title here, LiDAR and IFSAR-Based Flood Inundation Modeling. What we're doing is using drone-acquired LiDAR, so the drones are doing more than going after people. They are collecting, it's the Buckeye program, and they're collecting LiDAR and orthophotography and so on. A lot of good information. And so we used those to put into our flood plan model, a simple name, to come up with some ideas of what kind of inundation patterns we might see in Afghanistan. Overall, this was a DoD-funded project. The money came through ARO, and people involved here, Jude Kastens at the Kansas Biological Survey would develop the model. Co-developer was Kevin Dobbs, who's on leave at the State Department. Gwen Macpherson, hydrologist. Melissa spent the last 2 years at a workstation. So let's take a look at what we've come up with. This will be a quick survey. We have to realize, of course, which we all do, that Afghanistan typically has too little water. But of course, when it does come, there's too much, springtime in particular. And well expressed in these, a lot of papers that have come out, this one from Kabul, talking about the issues with both floods and droughts. Our objectives, we were charged with looking at the water issues, both too much and too little, that are very prevalent in Afghanistan. And so our first objective was to look at the status of the traditional strategies for extracting groundwater. The Kanats, they're called Kareez systems, these underground collection systems. So that's what we did in our first phase of this, and now we're working on the flood inundation mapping. We've done most all of Afghanistan at anywhere from 1 meter XYZ up to IFSAR at about 11 meters. So here we are, Afghanistan, Hindu Kush, coming out here, so we have a snow supply. We're looking at the flanks of that, where we have rainfall and snow melt coming together, so it can be really a hazardous situation. So the flooding, really bad along the north side, and to a lesser extent over in here, and somewhat on the west side. Many of the publications have come out, issued. This one is from the State Department. You can see this was 2012, I think. These were flood issues where we had loss of life and loss of property. We put the superimposed population on there, and you can see, well, the people are where the flooding is occurring, because there are no situations where we end up with really very deep inundations. More of this kind of thing here from the United Nations and then from USAID. 1,200 families displaced, loss of life. This person here has built his home repeatedly in the last 10 years. So a very harsh environment. We look at the snowfall, the snow melt. Here we are for a bit of geography here. Here's Herat. This, you can barely see it. I should have darkened it, but the line along here, this is the Iranian border. Another landmark might be the Helmand River. Kandahar be right over in here. Helmand River runs down like so along the west side of the Registan, the Red Desert. The Sistan Basin over here where you see the water. Let's focus in on this area right here and look at the snowfall, the snow cover. The arrow indicates Herat again for reference. Here we are in January 2011. We go a month later. We see that now, of course, water's come, snow's gone. We had rainfall associated with this. So in between this time, we had water going into the basin, as well as green up over here, but also we had catastrophic flooding, which was occurred in between those two dates. And of course, here's the Pacific Disaster Center information showing rainfall typically comes in on that northern flank of the Hindu Kush. And here we can see the UNISAT predictions of rainfall. And that's for 2014, this spring. So inundation modeling, most models, of course, are based on algorithms developed in the developed world where we have lots of data. The nice stuff, HEC-RAS is a good example of that. Necessary inputs, generally not available in places like Afghanistan. We do have some good information, Bob's DFO, the Dartmouth Flood Observatory data, and other sources. Most developing countries really need this, and of course Afghanistan is no exception. And fortunately, we do have DEMs available at various resolutions, XYZ data, so we can make these DEMs that can be used. So what can we do with a DEM? Well, the model we're using, the one that Jude Kastens put together with Kevin Dobbs, is called floodplain. Not a lot of imagination here. It means floodplain. But what does it do? Well, it uses a standard ArcGIS hydrology tools. First, you fill the cleanup, basically, the DEM. Here we see the hillshade. Then you determine the flow directions, flow accumulation, and then stream channel. And then in the lower part, those data are then fed into the model, which then pixel by pixel fills and spills into the next one. One part of it that's pretty important is when you have an obstacle, it won't flow around, it'll spill over, so you don't have these shadows where you have no water or a lower amount of water. You can see the difference here in terms of the resolution. These surface flow patterns show that in the IFSAR. This is a small basin. It's about maybe 15 kilometers long. You can see IFSAR here, and then over here you can see the LiDAR. And just popping in at the top is pretty hard to see, but it's showing the drainage network in IFSAR and then along with the LiDAR. We also resampled the LiDAR down to up to 5 meters, so we have 3 levels of resolution. Let's go to some spots now. Okay, we've been here, we looked at the snow melt in Herat over here. Let's go to the Helmand River. I'm trouble with your pointer here. The Helmand River. Okay, I'll just leave it on all the time. The Helmand River, and then over here we have a small tributary. We're just looking at the IFSAR data from there, the flow pattern. And then we'll head up to, we'll head over here to to the provinces on the east, and then come up to the north, Seripol. So here we are on the Helmand River. This is our 5-meter model. We can do it in 25-centimeter increments. Of course, a lot of computing time, especially if you're using LiDAR data. But you can see here, this is a 5-foot. Here's, of course, the image. 5 foot, you can see what we get here. The blue, of course, would be the lowest. So if you take a cross section, your lowest value would be the dark blue. And then coming up to the 5 meters, of course, you're starting to get out here where you get the oranges. So that's why we call it depth to flood. It's kind of a wacky term. But anyway, over here we go to the 10 meter, and you can see what happens now. We're across the valley. So shows the differences, and we can show that. I had an animation, but it wasn't going to work here. That was going through one and on to the next at 1 meter increments. To look at it in another perspective, here we are down on an ephemeral stream, and you can see the thing just in the image here. Let's go to the DEM, then we'll transition into the LiDAR hillshade, get a little bit sharper there, bring in all the data, and then look at the cross-section right here. You come down to this cross-section, the active channel right here. What happens? You start to put in water. The 5 meter comes up to about here. You go to the 10 meter. Of course, we could have gone at 25-centimeter intervals, but there's historic flood evidence, in fact, recent flood evidence or documentation where the water is over across to the east side there. So we know we're getting up to about, the 7-meter mark, somewhere in there. So again, all too common flooding on that one side where it's a bit lower. Now, what are other approaches to flood hazard mapping? I'll bring in the one that Hagens did, because he produced a flood hazard map for Afghanistan as well. And both these models are being developed independently without each other's knowledge a few years ago. How are they different? Flood modeling, they both use high-resolution DEM, use the hydrology tools in ArcGIS, but with regard to the Hagens model, he uses historical flood heights, so he needs data to anchor. And so here we go to Afghanistan again, and let's look at this little basin down here. That's that same one we looked at before. And let's go to this spot right here towards the end of it, right where it goes into this tributary to the Helmand. So it's right north of the desert. We look at that. This is just a clip from Hagens' map, and then we'll take a couple of ours. So those are 2 different colors, just simply extreme and not so extreme flooding. But here you can see ours at 10 meter for the same area. You can kind of lock onto this edge where this schist comes down to that little ridge. You can see it here, and we'll come to the next one, which is 5 meters. So you can see the difference. His isn't bad and ours is good, but we're just operating at different levels of resolution. But they do look a little different. Here we are looking at another stream system off to the east. And here's the one he produced in the QI publication. And then we go to our rendition of that. And you can see a little bit different. Of course, we're running here. This is IFSAR data, so this is about 11-meter resolution. What about validation, lastly, here? Surrey Pull, now we've gone up to the north, and take a look in here. And we're going to look at this particular stream system, the main stream system in there, specifically where the little box is, and move in on that. This is from Unisat, so now we're seeing some flood inundation that was determined using satellite data, imagery. And so when we start to pile in ours, here we're going to our 1-meter model, our 2-meter model, our 3-meter model, our 4-meter model, and I couldn't get it to show very well. I had a 4.5-foot meter model, and it seemed to really nail it. But this is pretty close. So it's a little bit of this kind of validation. Of course, the thing's also been validated from several spots in North America, the Susquehanna, down in Texas, Kansas, of course, the Pacific Northwest, a couple spots in Canada, and more recently in Iran, where I have a student working. Not Iran, sorry, Iraq, Kurdistan. So, based on hydrologically corrected file or filled DEMs, both work, produce you with data for you. Floodplain's a little bit easier to use. We don't have to worry about anything. We just live in ignorance and just use the DEMs. And we're getting really high accuracies. I just couldn't remember them exactly, what Jude told me, but I just tossed that out because they are very close. The model's been really validated using these data from places where we've had recent flooding, and we have precise high water marks, and so it's really nailed in there. So regardless of approach, though, these things really have some potential, these models, just using DEMs or maybe with a little bit more data that Bob Brackenridge's group is supplying or some other source. Thanks.
We have time for a couple of questions. Any questions? Yeah.
Right, Paul.
How did you decide on your 5 and 10-meter flood height? How did you constrain those?
Oh, well, we just use those instead of 2, 3, 4, 5, 6, 7. Is that what you're asking? Yeah. We just picked those, and we ran the models at that. Have you met Kevin? I think Kevin, I thought you had. Yeah, that's what we've done. Otherwise, it would take more time to run through those. But we have been doing them typically at 50 centimeter, half meter. Yeah, thank you.
Any plan to constrain the recurrence interval or seems probability?
Yeah, but that's down the road. We need to do more validating on this, make sure we're nailing it there and more sites. I'm kind of sort of answering your question, but yeah, we just finished. It took a long time just to finish the country data transmission and so on, because we had to go through the military paperwork and so on.
Okay,